Hello future engineers and my dear students, welcome back to Mudassir Academy. I am Mudassir Sheikh. In the previous video, we learned how to find a solution of first order ordinary differential equations. We worked on problems on exact differential equations, reducible to exact forms, linear, reducible to linear form, the Bernoulli's form. And in today's video, we are going to learn how to apply this solution to find orthogonal trajectories. Well, first of all, what exactly are orthogonal trajectories or OTs in short form? See, orthogonal trajectories are simply two family of curves that intersect each other at right angles, meaning at 90 degrees. It means at every point where they intersect, their tangents are perpendicular to each other. That's it. So let's leave the theory aside. We are concerned about solving only the problems here. So when we are finding the orthogonal trajectories of the family of curves, we need to discuss two curves. One is the Cartesian curves and other is the polar curves. Cartesian means which has x and y, polar has a radius and angle theta r and theta. That's it. Okay. Or we will be discussing how to find the orthogonal trajectories for family of Cartesian or Cartesian family or the polar family. Both have different methods. So in today's video, I will be focusing only on finding the orthogonal trajectories for family of Cartesian curves. So let's see the method employed here and how to find the OT using that method. So let's move on. A Cartesian curve is something which has x and y in the equation. So while discussing our Cartesian family, let's say given the Cartesian equation as f of x comma y comma c equals 0. Here c is say constant. Okay. So first what we do here is the method is like we have the question given. What to do first? We first differentiate with respect to x to eliminate the constants. Very important point. So here constant is c. So we differentiate such a way that constant c is eliminated. It's gone. After differentiating, simply replace, this is the main part here, replace dy by dx by minus dx by dy. After replacing, we simply solve the equation. We solve the equation to get the orthogonal trajectory for the required family. So first, the question is given here. Okay, the Cartesian question will be f of xy comma c is equal to 0. Here c or what they'll mention a constant. We need to differentiate to remove the constant first. Whatever constant is given, you are able to remove. So we remove the c here, c is eliminated. Then differentiate. After differentiating, this is the main part. We replace dy by dx by minus dx by dy. Okay, we solve the equation. After solving the equation, we get the orthogonal trajectories. As simple as that. So let's understand this, method, a very simple method for solving a problem here. So let's take this problem. So we have find the orthogonal trajectories of the family of parabolas y square is equal to 4x. A very simple question. So if you look at a question, we have y square equals 4x. It's a Cartesian family. Now we need to first differentiate and remove the constant a. Here a is a constant. Okay. So see, one way is I can differentiate it. Differentiate y square is 2y divided by x is equal to 4a into 1 4a. So right 4a will be retained. It's not eliminated. So I use some brains here. Okay. So I'll do such a thing that I will remove that 4a one shot. So what I'll do, I will write this as, if I take 4a right side, differential 4 is 0. That's it. So I'll write as y square by x equals 4a. Simple. Correct. Now we differentiate with respect to x. Okay. So while differentiating, we'll use the quotient rule here. What is the quotient rule? U by v or differentiation of first by second function is whole bar, the denominator second function square, and in numerator second function as it is, differentiate the first function minus keep the first function as it is into differentiate second function. Okay. So let's apply the quotient rule here and differentiate. So see, this is first, second function, we have x square, x as it is in numerator. Okay. For those who are finding difficulty in question tools, listen carefully, lend ears to me. Denominator square, denominator as it is, differential y square, chain rule is 2y into dy by dx minus y square as it is, differential x is 1 equals what? Differential of 4 is 0. See, my constant is eliminated. The first step is over. For the Cartesian curve, differentiate with respect to x and remove the constant. Okay, whatsoever. After removing, let's organize it. So we have 2x y dy by dx minus y square equals 0. Okay, again we see here this x square goes to the side to become 0. Am I right? Now again see y is common, so I can eliminate y here. We have 2x dy by dx minus y equals 0. Over. Now the main heart of the problem of solving the orthogonal trajectory for family of Cartesian curve is only one thing, that is replace dy by dx by minus dx by dy. Very, very important. Replace dy by dx by what? Minus dx by dy, as we discussed in the theory or the method. So what we get here? 2x dy by dx minus y is equal to 0. Here we will replace dy by dx by what? Minus dx by dy. So 2x into minus dx by dy plus, minus y equals 0. Now let's again rearrange it, because we need to get it in differential equation form and then solve it and get the answer. That's it. Obviously the differential equation will be easy form, it will be direct integration form. Okay, so we can write minus 2x dx, take dy this side, minus y dy is equal to 0. Now let's make it standard. So minus minus cancels, we get simple solution of equations plus y dy is equal to 0. So x dx y dy, simple solution is integration. So we have integration of 2x dx plus integration of y dy equals a constant c. Now integration of 2, that implies 2 into x is x square by 2, as you all know, plus y is y square by 2 is equal to c. Again that implies 2 cancels here, x square we have, see here 2 cancels, we have x square plus y square by 2 equals c. So so what I do is I'll take LCM of it. We have 2x square plus y square is equal to 2c. Now constant is a constant, so you have to make some adjustments here to get the solution in standard form. So we have 2x square plus y square is 2c is the solution, 2c is a constant. So constant is a constant, we can take 2c as k or alpha, whatever it is. So I take 2c as k, that implies 2x square plus y square is equal to k. So this is the orthogonal trajectories. This is the orthogonal trajectories required for the family of curves or family of parabolas. Y square is equal to 4x. That's it. The next problem is find the RT, that is orthogonal trajectories of the family of asteroids. X is to 2 by 3 plus y is to 2 by 3 is equal to 2 by 3. Okay, the asteroid is a star-shaped curve. Okay, so we have the equation here. The equation is x raised to 2 by 3 plus y raised to 2 by 3 equals a raised to 2 by 3. It's a Cartesian curve and here is the constant. So what we'll do? We will first differentiate with respect to x and remove the constant a. Okay, direct differentiation is possible here. As you know, differentiation of x is to n is n, x is to n minus 1, the simple rule. So apply it here. So differentiate with respect to x. We have 2 by 3 x raised to 2 by 3 minus 1 plus 2 by 3 y raised to 2 by 3 minus 1 into again chain rule dy by dx equals 0. Okay, now this 2 by 3 won't be there. Okay, because right side is 0. So we have this as x raised to 2 by 3 minus 1 is 3, 3 minus 1 minus 1 by 3 plus y raised to minus 1 by 3 into dy by dx equals 0. Okay. Now, for the method of finding the OT for the orthogonal trajectories for family of Cartesian curves, we first differentiate, removes the constant. Then we replace, very important step, dy by dx by minus x by dy. So right here now, replace dy by dx by minus dx by dy. Fine. That means we have x raised to minus 1 by 3 plus y raised to minus 1 by 3 into minus dx by dy equals 0. Okay. Now, let's rearrange this now. So we have dx by dy. Okay. I cannot take dy this side because x is there. So what I will write is, that implies dx by dy equals, see, if I take dy this side, dx will this side, so I cannot integrate because to integrate the variables x should be with dx, y should be dy, so it is not possible. So what I'll do is, I write dx by dy as, take this side, minus, I'll write minus dx by dy as, because there is a minus sign here. Okay, take it this side, minus x raised to 1 minus 1 by 3 upon y raised to minus 1 by 3. Correct? It will use little of a brain techniques here. Now minus minus cancels. That implies dx by dy equals, minus minus will cancel here. So we have x raised to minus 1 by 3 upon y raised to minus 1 by 3. That can also be written as, see, it is x raised to minus 1 by 3 upon y raised to minus 1 by 3. It's a simple mathematics. X raised to minus 1 by 3 can be written as 1 by x raised to 1 by 3, and 1 by y raised to minus 1 by 3 can be written as y raised to 1 by 3. Take it down, take it down. Okay. So we have, this goes top to become y raised to 1 by 3 upon x raised to 1 by 3. Simple maths. Now cross multiply. We have x raised to 1 by 3 dx. Okay. Minus, I take this side, y raised to 1 by 3 dy is equal to 0. See, both the variables are separated now, x with dx, y dy. So solution is ultimately integration. We have integration of, solution is now integration of x raised to 1 by 3 dx minus integration of y raised to 1 by 3 dy equals, the constant of integration is c here. Now as you know, integration of x raised to n is x raised to n plus 1 by n plus 1. So this will be again x raised to 1 by 3 plus 1 by 3 plus 1. I write each and every step, minus again y raised to 1 by 3 is y raised to 1 by 3 plus 1 upon 1 by 3 plus 1 equals c. Again, that implies 1 by 3 plus 1 is 4 by 3, x raised to 4 by 3 upon 4 by 3 minus y raised to 4 by 3 upon 4 by 3 equals c. Okay, what I'll do, we take 4 by 3 that side, we have x raised to 4 by 3 minus y raised to 4 by 3 is equal to 4 by 3 c. See, constant is a constant. 4 by 3 is constant, c is constant. So it's a constant. We can take constant as a whole, use some simple arrangements here. So we can write this as, this constant is equal to nothing but implies x raised to 4 by 3 minus y raised to 4 by 3 is equal to, I take this as k. I think I'm done with the solution here. So that implies the solution is, we can write x raised to 4 by 3 minus y raised to 4 by 3 is equal to k. This is the required orthogonal trajectories for the family of asteroids. X raised to 2 by 3 plus y raised to 2 by 3 is equal to a by 3, and That's all in today's video. I hope you clearly understood how to find the orthogonal trajectories for the family of Cartesian curves. In the next video, we'll be solving problems on finding the OT for polar curves. So please stay tuned and also see the problems which they ask in the VTU examination for this might be the Cartesian polar curves are very simple. Okay, so if you practice it thoroughly by watching the videos, you can score full 6 to 7 marks in that. So please do that. Also, there are a couple of more examination related questions on Cartesian curve. So if you want me to solve them, then please drop a comment below on which questions you want me to solve in the further videos. And if you find my explanation, the way I teach really helpful, then please do subscribe, share these videos with your friends and classmates as much as possible, and do good work. Stay curious, keep learning. See you in the next video. Bye.